I'm going to share Chrome because that's where it's set up. So move you, there we go. That drop down menu. Okay. As you can see, what I did is I set up a box at the top of the home page. And this is the video for yesterday. You see it's an MP4. My videos from the Ladybug is an MOV, and MOV, it just takes forever to upload. This guy uploaded in a matter of minutes. So that's the video from yesterday's class. I will go ahead and I will upload the video from today's class as well. I'll probably do the same for Monday and Tuesday because those are review days. And then this is the final exam review list. I sent this to you last night. I don't know what time I sent it. Probably close to about maybe 10 something last night when I finally got this finalized. And it just says the first available final time is going to be Wednesday from 12 to 3. And you need to let me know if you're planning on taking it then or if you want to take it some other time. We're working on that today, tomorrow, today, Monday, and Tuesday. And then also is the final exam review. That's the one I put together. And I sent this to you as well. And I went through, what is this? I didn't remove that. It's an old final exam. I've changed some of the questions and put in new graphs and that kind of stuff. So I use an old final as a now all the questions are on here because you'll see there's going to be fewer questions than what's going to be on your final, but there's a mix of everything. So there's a graph and then the limits from a graph. There's these things. This guy, you have to use L'Hopital's rule on. You don't have a choice. These guys you can do in different ways. This one's a plug and chug, plug it in, number in, number out. This one you could do either using algebra or L'Hopital's rule, either way. I think on the key itself, which I'll upload on Monday, the key itself, I think I did L'Hopital's rule. And then here's a couple of derivatives. This is the basics. That's basic chain, basic, and then just the basic derivatives. I didn't need to have derivatives continued. This is product rule and quotient rule. This is second derivative. Absolute max mins. Now here you actually have to do the derivatives. I don't give them to you. I may give them to you or not because I'll be writing the final exam this weekend. This is easy enough for you to be able to do without too much of a problem. And of course, this is increasing, decreasing, maximum, or minimum. That's the way your test is going to look. If I give you something to differentiate, it'll look like this. If I put the derivatives in, you'll see the two derivatives. Depends upon what kind of problem I give you. This is integration basics. This is U sub. This is the definite integral. These are integration by parts. I wonder what that, I didn't need to have that. That might have been from whenever I merged pages. This is an improper integral. And this is the area under the curve. So that covers all the types of problems that's on the final. There are more of them, but this gives you at least something that you can practice on. And then hopefully this is right. I was going to recheck it this morning, but I think I didn't get to bed till almost midnight. So I didn't get up until I guess about 5:30. So I was going to check the answers, and then here are the answers. So you know whether or not you've got them right. And like I said, I'll upload the key on Monday. because there is a key. So that's all set up, beginning to help prepare you for the final. I'm going to go ahead and reload that so that closes all that stuff out. So I have sent you, at least I've sent you these two things. May have not sent you the answers, don't remember. It was too late last night when I sent it out. So, and I'm usually up around somewhere around between 4 and 5 most of the time because my first class is at 8. So, so at that point, I know I sent you these two. Don't remember whether I sent you that. If not, the answers are there. So you know whether you got the answers. So then I'll put today's video from today's class here. Link that there. And kind of go at it from there. So any questions on what's going on in Canvas? And you guys tend to use a chat box more. Let me bring that down. And remember to take the roll. I'll do that shortly. Doesn't show me right now how many are there until I hit open poll. Then I know how many people are there. So we okay? No questions? You guys are driving me to drink. Okay. Let's move to the, whoops, doesn't help you any because I'm not sharing it. Okay, WebEx, share, content, Ladybug. Oh, I did send you this too. I sent you the, Max, did you get that, the worked out version of that problem? Because that was your question. And so, yeah, I looked at the video that went along with it. They pretty much did the same thing. What I'm going to do with this quiz, I'm going to take it down from 100 points to 1 point. So you either did it or you didn't do it. If you did it, you get 100. If you didn't do it, you get 0. So it's either 100 or 0. Mainly because of this problem right here. I've got to go back in. I've got to back because some of you would have had issues with this thing, like Max did, which is why I sent you a copy of that. So, and that, well, that was an answer. That's not the correct answer. And so no matter what, when you're doing a parts problem, best teacher ever. Yeah. I don't feel like it at the moment. Well, feelings don't matter. Anytime you're dealing with parts, natural log is always going to be what you're going to differentiate because you don't know how to integrate it. So that you know then the du is just 1 over 2x plus 9 times 2 dx, right? So that basically is u. That means that leaves this guy for dv. So that dv is just dx. So that v is just x. And where you get yourself into a problem with this particular problem is now when you 7 it, it's going to be x natural log of 2x minus 9 minus the integral of x times 2 times this thing. So this is going to be actually 2x over 2x plus 9 dx. And this is really not something, I did work a problem similar to this at one point in time. And then I said, yeah, I really didn't want you to get into the weeds on this kind of thing because we don't know how to do this kind of problem. We didn't cover it. Let's put it that way. I didn't emphasize it. This basically is algebra for that integral, because this is 2x over 2x plus 9. So you actually have to perform the division. Then you have something you can do. Because anything after that is going to be 0. So what do I multiply 2x by to get 2x? You'd say 1. So this is 2x plus 9. Then you subtract, which changes the signs. 2x drops out. Then I end up with a minus 9. So this is 1 minus 9 over 2x plus 9. And you can integrate this because this is just natural log, and that's just x. So you get x natural log of 2x minus 9 minus the integral of 1 minus 9 over 2x plus 9 dx. Yes, you can do that, unfortunately. This is not a STEM class, so I try not to take you too far into the weeds. The integral of 1 is easy. That's just x. So it's minus, then plus. Minus times a minus is a plus, and it's going to be the integral, this guy. And that's a well, you could say it's a U sub if you want. Because if I look at to the side, the integral of 9 over 2x plus 9 dx, u is 2x plus 9, du is 2 dx, or 1/2 du is dx. So this becomes the integral of 9 times 1/2, 1 over u du. And that's just natural log. Right. So when I come back up here, this is x natural log of 2x minus 9 minus x plus, well, plus what? This thing, natural log of u, which happens to be 2x plus 9, and then plus c. This is the kicker right here. That's what, by the way, this is why I've always said you can usually not get me on a derivative because I can differentiate about anything that moves. You give me an integral, and I may have to sit there and say, what in the heck am I going to do with that? And then I have a checklist in my head. Is it a basic? No, if it's a basic, I could easily do that, right? Is a U sub? No, it's not a U sub, because if U is the denominator, which is what it has to be, how in the heck am I going to get that X out of there? Is it a parts? Well, not really, because who am I going to make U? I can't kill this X. This X is what's causing me the problem. I can kill it by differentiating it, but then I end up back where I started from with a natural log. So then what do I do? The only thing that's left for me from this class, if I were in a STEM, it's a different issue. I have about 4 other things I could try. Algebra. But algebra would work because 2x into 2x is 1. Then I'm left with a constant divided by this thing. So 2x into 2x is 1. Then I'm left with a constant. Then I look at that and I say, oh, that's natural log, except for constant. Because if I differentiate 2x minus 9, what do I get? 2. So it's natural log. So yeah, that's why I'm going to have to basically say you either did it or you didn't. because I really didn't want to spend a lot of time taking you through problems that were that complex. I don't think you really don't have to do something which is that complex in parts in 213 or 218, excuse me. So that's where that problem was coming from. So that was Max. That's for Max. And that's a copy of the answers. And then here's this thing. Uh, I don't know which you had time to take a look at. Is there anything from either of these? Since we're going to be spending today, Monday, and Tuesday reviewing, so we've got 3 days that we can do all kinds of stuff. Is there anything that you want to see worked between your tests and the final exam review? Anything, guys? Another problem like the last problem? Uh, Good question. That's one I had in class. I think it was this. Something like this. And that was one of the handouts I gave you. And I may not have that. So I can put that on my list for Monday if you like. Because unless I can find the actual handout of the problem I was thinking of. And right now I'm just buried in paper. This one. Yeah, what's this problem? I don't want to write on that. It was this guy. This was from the integration by parts practice where I crashed and burned, and I've got to take this off if I'm going to use this in the fall or in the spring if I have this class again in the spring. Don't know. My schedule can change. My fall schedule won't, for the most part. That's all my classes made. That was the one I had in class. And I like this problem because you could use the properties of logs on it. This is just a constant. It's just a number. So if I wanted to take the natural log of 12, today is a bad allergy day, it's about 2.5. So this integrates out as the natural log of 12 times x. And then this is the integral that's the problem. Because this is what happens. I look at this has to be parts. Because I don't know how to integrate natural log other than by parts. And I have to kill it. Because 1 over and the derivative of x plus 1 is just 1. That means if this is u, then this thing has to be dv. That means v, when I integrate both sides, is x. So that when I 7 it, this becomes the natural log, and I'm going to put the x in front of 12 minus whatever is going to come out of this thing. It's u times v minus the integral of v du. Notice I have an x in the numerator and denominator. That's the thing that got me right there. Because if that weren't there, that's just natural log of x plus 1. But unfortunately, where'd that x come from? And if I were going to try to do parts on this thing and do my normal and say, well, I got to kill the x, then I would say that du just equals dx. That leaves then dv is 1 over x plus 1 dx. And I say, oh, I can integrate that. This is just the natural log of x plus 1 dx. Now, when you 7 it, you end up with x natural log of x plus 1 minus the integral of the natural log of x plus 1 dx. And I got to do, and this thing here is parts again. Didn't I just do something? Because it's natural log. That's what I did originally to kill him off. So notice, where am I? Back at the beginning of the problem. Because u is the natural log. dv is just dx. So I'm going around the tree. In other words, I'm going in circles on this problem. So that says this is not a parts problem. So once I've convinced myself it's not a parts problem, the only thing I have left in my toolbox is algebra. So I take x plus 1, I perform the division. What do I multiply x by to get x? You get 1. 1 times x is 1. 1 times 1 is 1 times x is x. 1 times 1 is 1. Then you subtract, which changes the sign. I get a minus 1. This is 1 minus 1 over x plus 1. And just notice now that's integrable. Because the integral, if I integrate this guy now, this is x. This is the natural log. So that really is what replaces that there. So that becomes x natural log of 12 minus x natural log of x. And then minus x. And then plus the natural log of x plus 1. I mean, it's kind of like when all hope is lost try algebra, which is why I didn't want to take you down that rabbit hole. We don't, I try not to in this class because of your requirements for future classes. Now, if you're going to be an actuary, like one of my students in 150 is planning on doing, or you're going to go into economics, or you're going to go, they're going to have a set of requirements where the classes are going to be very extensive. Then they'll go deeper into some of this stuff. But like for my best friend's granddaughter who now works for Amazon, who is in, and it came and gone, what she does in terms of merchandising, she doesn't need to go this deep. If you're going into accounting, you don't need to go this deep. And some of the other majors, you don't need to go this deep. If you need to go this deep, you're going to be forced to, you're going to be taking classes that's going to force you to go that deep. And I let them worry about that and not do that here, because why take you down a direction which is going to be kind of an overkill, which is why when I put that problem in that handout, I found out what it was. But it's that same idea that was in that problem in the quiz. You had, once you hit this, it was algebra. You had to do the division. Nature of the creature. Which reminds me, I can't lose this paper because I've got to fix that if I'm going to use it in the fall. Does that answer your question, Eduardo? Anything else from anybody? Yeah. But I just don't, it's not going to be requirements for the final. So that's why I'm just not going to sweat it. Or let's put it this way, make you sweat it. So anything else you want to see? Oh, max min increasing and decreasing, an inflection point. Okay, that is so nice not to worry about videoing this guy. Well, if I'm doing max min increasing and decreasing, this is the first derivative. So my function is h. So this comes off of h prime. So I want to find I need to change that. H prime of x equals 3 times 3 2/3. That's why I use those fractions. And that is 2x squared plus 2 times 1/2. 2 times 1/2 is just x because it kills the fractions, minus 6. So this is f prime. So you're going to set that equal to 0. And get your critical numbers. So this is 2x and x. This is 2 and 3. 2 is a 4. 3 is a 3. So outer that's a 4. That's a 3. You can use a quadratic formula if you have to. That's a plus. So the 4 has to be plus, and the 3 has to be minus. So x is 2/3, and x is -2. So those are your critical numbers. They're either maxes or mins. Since this doesn't have a denominator, I just put this on the number line. -2, 2/3. Pull a test point. X equals 0 is available to me. So x equals 0, gone, -6. That's why I like negative. I like 0. Negative, and these are all multiplicity 1. Change, positive, negative, change, positive. So positive to negative, this is your max. Negative to positive, this is your min. Let's see. I've got a plus x. So if I have a plus, my pencil, the outers are 4x. So that's a plus 4. The inner is minus 3x, and then plus 4 minus 3 is plus 1. Yeah, and it's a good thing to check on me. So my allergies are giving me a fit today, so it's kind of one of those things. And I've took medication, which is another thing. So my mind might be a little foggy. So I know my maximum, that's my hill, is at -2. It just says find the x values. And my minimum, that's my valley, is at 2/3. Those are the x values. That's all you're asked for. And then it's increasing where I have pluses, minus infinity to -2. Then it decreases between -2 and 2/3. And then I increase again from 2/3 to infinity between the ladybug and these papers on the side. I'm running out of space on my table. That's why things get a little blurred. Okay. Now, if I want to find concavity, that's H double prime. So here's H prime. H double prime of x is 4x plus 1.
For the first one, isn't x 3/2? Or am I seeing this wrong?
No, you're right. It's 3/2.
Okay.
That's my 2-3 thing. You know that. I even had typing problems with 2s and 3s last night. Look at that. I did it again. I think I need something stronger than a Diet Coke. It'll go away. Let's make cross-check now to make sure. Yeah, it's okay on the key. So that's good news. And yeah, well, the only thing I do is one test point because these are multiplicity 1. I know it changes across. Now, I could pull a test from here, and I could pull a test from here if I wanted to, but I use multiplicity, so I didn't have to test. I didn't have to pull additional test points. So I only did one test point. And these are multiplicity 1, so it changes across. So, which is why I didn't put the additional test points here if you use multiplicity. H of 0, no, because it's not a max or a min. It's just telling me, or H prime of 0, it's just telling me that it's decreasing. No, not into H, you plug them into the prime. Because with a prime, remember, it's telling you the direction, so it's directional. If I wanted a coordinate point, the coordinate point would be -2, H of -2, if I wanted a coordinate point. But you weren't asked for a coordinate point. You were just asked for the X values. Yeah, so this is 0, it's negative, so it's decreasing, yeah. So negative slope means going down. And of course, positive slope. So this is decreasing. This is increasing. So it's telling you the slope of the tangent lines. So that's your increasing, decreasing. And then I set this equal to 0 so that X is -1/4. And I think I've got an error on the key if this is correct. Because this is negative. So when I take this derivative, that's positive. So this is positive. If this is positive, when I take the derivative, this is 4x plus 1. So when I take the derivative, when I solve here, I get a -1/4. So on my answers, this should be negative. So I'll make that correction and repost, which also then means that these guys are going to be negative. Because now this is -1/4. So I pick 0. And at 0, 4 times 0 is 0. This is positive. Multiplicity 1, change, negative. So this is concave down followed by concave up. That's an inflection point. Is that at -1/4? It's concave down from -infinity to -1/4, and then concave up from -1/4 to infinity. At least that's right. The only difference is it should be -1/4. Okay. But like I said, this is the template from the final, from a previous final. I'm not going to ask you to graph it. And let me take roll so I have it so I don't have to go to WebEx and get it, because it's a pain to do that. Any other questions? Yeah, so negative means concave down, positive means concave up. Seems like a century ago, right? Any other questions? And I have to fix the answer key. And I've got to check. I knew I needed to cross-check that this morning. I just didn't. Can I do number 1? I may have to send you another one over the weekend. Most missed question on the first test, you still miss it on the final. And what I ended up having to do with this, because I don't draw them myself. I got it off the internet. They didn't mark the boxes. So we're going to -6. So 1, 2, 3, 4, 5, 6. This was -6. So I had to make sure what -6 was. -6 from the left. I moved to the graph directly. From the left, I'm coming up this direction. And where do I stop? I stop at -1. So this is -1. And then from the right, I'm coming in from this direction. And where do I stop? 1, 2, 3, 4. I stopped at 4. Cross-check is what we're doing it. So I have to make changes to the answers. From -1, I'm coming in from both sides. So here's -1 on the X. Coming in from the left, I stop at 2. Coming in from the right, I stop at 2. And notice I'm actually marking on the graph. To infinity, I'm following the graph as it goes out, and it looks like it's going to be a horizontal asymptote, so it's 0. And then 3 from the left. So 1, 2, 3. Here's 3. From the left, this thing continues to go down. So that's -infinity. And then at 1, here's 1. Come in from the left of 1, I stop at -1. Right of 1, I stop at -1. And so it's -1. But I drew on the graph directly because you remember the limit is a y value. You swear it's way harder in the exam? Oh, I don't know. Here's the exam that you took, right? X goes to infinity, that's this guy. So he's going to 0. X goes to 1 from the left. Here's -1 from the left. He's at 2. Or left, I'm sorry. Left. He's at 1. 2 from the right. Is -infinity. Just 1 itself, left and right, they two meet, but it's going to be a 2. At 2, left is up here, right is down here at 2, so this does not exist as it separates. -1, period. From the left, you end up here. From the right, you end up there. They're separated. So that was the one from the exam. So -1, they were separate. And at 2. So. Wouldn't 1 be 3? If I'm coming, which one would you want? What do you mean, what wouldn't 1 be 3? I'm not sure what 1 is you're talking about. D. Okay, at 1. No, because the dot's up here. So essentially, since you're riding along the graph itself, you ignore anything that's not on the graph. So that's what made it 2. Because otherwise I'd have to jump up here to try to get 3 and then jump back down. 3 is just a really itty bitty. But if I'm on the graph, I mean, I'm very close to 1. To the left of 1 would be 0.9999 dot, 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 right? And to the right of 1 would be 0.000, would be 1.00000 dot, 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 1. So as far as we're concerned, when we're getting close to 1, these would be the X values. What would the Y value be? The Y value would be coming toward 2. This would be 1.999 dot, dot, dot. On the other side of it, it would be 2.000000001, something like that. That may be, but you're not, oh, but you're not asked what f of 3 is, or f of, this is the limit. The limit is different than the function value. Yeah, f of 1 is 3, but the limit is 2. Yeah, so the colored dot is the answer for f of 1. Yeah. So if I would have asked you what is f of 1, you'd look for the colored in dot. That was 3. But the limit itself is 2. Good question. Most missed question on both the final and the first test is the damn graph. But what you try to do is you try to do the visual. You know, you don't look. That's why immediately I went to my pen on the graph. When it says going to infinity, I trace it and see where it goes. It says it's going to -1 from the left. I trace it and see where it goes. So as I put my pen on the graph itself, more than trying to not do anything and just looking right. Looking right can get you into too much trouble. It would get me into trouble. I mean, at this point. So yeah, use your pen on the graph. It helps you a lot in determining what the limit is. Any other questions? If there's anything that you would like to see, yeah, and if you want me to do another one of these guys to practice on Monday, I can put another one of these together. It's easy enough. I've got the template here. All I have to do is change the graph and then change the numbers in the limit. I can do that too. And I would do that, yes. And so we can practice on those. And then anything else you would like to see me put together, if you don't want to tell me now and you're working on it and you're taking a look at it to prepare for Monday, just fire off an email and then I'll put something together for Monday with your requests. Yeah, and then that way I know exactly, you'll know what you want me to cover and I know what you want me to cover rather than me saying, well, we'll cover this and then I don't cover the very thing you don't understand. So that way we can kind of work together on it. I will also video it, so the video will be there as well. So I don't want to lose this. This is my stack of tests, of your old tests. So I will see you guys on Monday. So you guys have a great weekend. Have a safe weekend. And hopefully I'll hear from you so you can help me put your review together. So see you Monday. And then I'll make that change on the actually I'll cross-check it against the key itself. I have time to do that now. And make sure everything is correct. So when I post the worked out key, it's correct. So see you guys Monday.
Did you already change that 100 points to 1% already?
No, I did not. I
Okay.
haven't even entered the grades yet.
Oh, okay.
So I'll enter the grades probably sometime tomorrow.
It's
So I
about
have-
the 6.3 quiz you were talking about, right?
Yes, this is 6.1.
A 6.1. Okay. Yeah. Okay, thank you.
So I haven't, yeah, so I'll enter those grades this weekend. Yep.
Okay.
So I had a few questions again. Oh, or technically not a few, but I was gonna say for the review guide, are you gonna post out like an answer, like the answer sheet and like with the work in it, or how does that?
Yes.
Yeah. Okay.
I'm gonna do that Monday. Right now, all you have is the answers.
Okay. The answers are on Canvas.
Yeah, so let me share. Chrome. I need to correct this because it needs to be a negative 1/4 instead of 1/4. But there's the review that I sent you. And then there are the answers.
Okay. Perfect.
Yeah. So there are the answers.
And then the last thing I was gonna ask you is, so you said we could use all of our formulas, correct?
Oh, absolutely, yes.
So is there like a way we could like put them all together, like because I don't think I have all of mine since
They
beginning
should
of
all
class.
be under modules. If you look, when we started doing derivatives, there's chapter 2 derivatives. And there's chapter 3. Yeah, it looks like it's there. It's just not, looks like I didn't post it. So here's all the rules for differentiation, another chapter 4.
Mm-hmm.
Didn't have them all. So if you look under chapter 4, those are all the rules for the derivatives.
Okay, sounds good.
And that should also be the case, as chapter 5 was integrals. And let me leave student view. I need to post that. I'll post that in because here is the stuff that I haven't posted. So well, actually it's that would be this guy, because parts, I think, I don't know whether I give you parts or not. Let me take a look. I'll go ahead and post this guy. So at least you've got all of the but parts. But parts is fairly easy because you 7 it.
Right.
So this is right here. So I'll publish that. So that gives you your integration review through USub. Just like you have it. And why did that not post? Publish. Update. There we go. So now this is visible. So that gives you now your integration sheet. The only thing that's missing is parts. And it'll give me time to work on something too. So this gives you everything the most important stuff, because there's only 2 parts. There are 2 parts problems.
That's good. So,
Yeah.
okay.
Yeah. Okay. So those 2 you can download and kind of put together for yourself. And then I'll look at some other stuff as I start putting your review for next week together.
So yeah, so yeah, perfect. It sounds all great. The thing is, so you said we could start taking the exam on Wednesdays, correct?
Yes.
So yeah,
Those who
I
want
might.
to take it on Wednesday. You don't have to take it on Wednesday.
Oh,
It just says that it's the first time it's going to be available is Wednesday from 12 to 3.
so
Because
it's gonna be like,
some people are going out of town, they need to take it Wednesday
right.
before they leave. So you could take it Thursday, you could take it Friday, you could take it Monday. Just need to let me know when you want to take it.
So it's gonna be Wednesday throughout class, or from 12 to 3.
Well, you could, if you have another time that's better for you, you just let me know what time. I just need a 3-hour block on a day. You just tell me what day and what 3-hour block, and I'll set it up for you.
Yeah, because I think I might have to be able to take it on that day, just to like get it out of the way, just to knock it out. But yeah, I guess I'll do Wednesday from 12 to 3. That'll be good.
Okay, so I'm going to ask people to email me to commit.
Okay, yeah,
So
for sure.
I have to do that now, but I'll ask people to do that beginning Monday next week.
Okay, yeah, that's good, just in case.
I won't be setting it up probably until probably sometime Sunday.
Perfect. Okay, yeah.
Yeah. And I know for sure one person because he's going out of the country, and he's leaving on Friday. So
yeah, so he has to take it as soon as he can.
so, yeah, he has to take it. Well, that would have been our normal regular time for the
Final.
Yeah.
Okay, just before the 2 weeks.